For more Microsoft webcasts, please go to microsoft.com/webcasts. Once again, ladies and gentlemen, I would like to welcome you to our MSDN webcast today, entitled The Visual Basic.net, Soup to Nuts, Classes and Objects. I would like to introduce today's presenter, Ron Cundiff. Ron is a MSDN developer evangelist for the Microsoft Corporation. And Ron, you now have the floor.
All right, thank you very much. Hello everyone, welcome to today's webcast. This is actually part 6 of a 22-part webcast series where we talk on everything visualbasic.net from soup to nuts. So today's topic, we're going to be talking about classes and objects. So in today's sessions, we're going to cover exactly, what is a class and why should I use them within my development projects. So we're going to specifically look at the class statement itself, and we're going to talk a little bit about constructors and how you go about and define constructors for your classes. Then we'll also talk about objects, because anytime you talk about classes, inevitably the discussion turns to an instance of those classes as well, which we call an object. So we'll talk a little bit about, what exactly is an object, how do I create them, how do I use them, etc. So first of all, we're going to talk a little bit about classes. Now, a class is simply a classification of something. So in modern development, typically what we do is we model classes as blueprints for objects, and of course these blueprints contain the definition of an object, and within this definition it contains properties about that object as well as methods or actions that object can take. So you think of a real world object. So for instance, a person. There are many different people in this world, and we all kind of start with the same blueprint, of chromosomes and so forth. Now, I am a particular instance of this class, this blueprint, and so therefore I am actually an object. So when you think about classes, think about them as blueprints for defining how we can create instances based on these blueprints, and each individual instance has a different set of properties that we can specify for this particular blueprint. So really and truly, if we think of the person, a person is a type of something. We know what a person is, but the computer actually has to have a pattern to base it upon. And so that pattern, or that blueprint, is referred to as a class within visualbasic.net. Now, how exactly do we create a class? We use the class statement within Visual Basic, and we can also contain within this class. It can contain a constructor as well. Now, a constructor is just a term used for initialization code that is performed when we create an instance of this particular class. Now, also within the class, we also define properties. So these are just descriptions of attributes for this particular instance of this class. Now, a class can also define functionality. So basically, actions that this class can take. So when we're talking about functionality, we talk about functions, methods, events, and so forth that we actually define for this class. And then basically this class now contains everything we need to operate upon an instance of this class. So we've got all the data related about this class. So for instance, in our previous example, person, age would be a property, hair color would be a property, maybe height, weight, etc. Those are properties. And then actions that a person object can take, may include saying hello, walking, chewing gum, etc. These are that would define actions that this object can take, and so therefore we would define the implementation of those actions within functions and methods that we create within the class itself. So really truly it's much easier just to go ahead and show a demonstration of creating a class as well as using classes and so forth. So let's go ahead and switch over to a code sharing demonstration. Now my resolution is set to 1024 by 768. So if your resolution is that or higher, you can press F5 on your keyboard to view this code sharing demonstration in full screen mode. So the first thing I'm going to do, first of all, before we jump into the code, let me give you a pointer back to my blog. So shortly after the conclusion of this webcast, I'll actually post all the sample code we're about to walk through here. I'll actually post all that sample code to my blog here. So once again, that blog address is blogs.msdn.com/Ron_Cundiff. So I've actually got that pulled up on your screen here that you should be viewing. And like I said, visit this blog shortly after the conclusion of the webcast, and I'll distribute all the sample code we're about to walk through. So before we begin, before we dive into any code samples, let's actually just go ahead and show you, exactly how you would create a class in Visual Basic.net. So I can actually come over here to my solution and then right-click on it in the Solution Explorer, and then I can hover over the Add menu to get a variety of options of items that I can add to this project. And one thing I can go ahead and just do Add New Item. Notice there is a shortcut here for going ahead and adding a class. Because it is a very common item to be adding to a project, you'll actually see a shortcut for adding a class right there off of the Add menu in Solution Explorer. So I can just go ahead and select that option. And as you can see, the class template is highlighted in the Add New Item dialog box here within Visual Basic.net Express Edition. And then I could just go ahead and type a name for this class. And here you can see that it's actually it's created a class using the class statement. So actually this is a keyword in Visual Basic.net, so maybe I should just do something like this, custom class. And then within this custom class, this is using the class statement to define this particular class. And then within here, Visual Basic.net Express Edition actually has some shortcuts that I can take advantage of right here within the editor. So for instance, if I wanted to go ahead and start defining properties for this particular class, I can right-click anywhere within this class snippet of code and insert a new snippet. And here you can see some common code patterns as a default snippet category within Visual Basic.net Express Edition. And here you can see that if I drill into that, another category would be properties and procedures. And so from here, I can just go ahead and select define a property. And as you can see, Visual Basic.net Express Edition kind of stubs out this property for me. So for instance, I could do something like, this, I can actually just tab between these values, and it actually has inserted the appropriate syntax for creating a new property that goes along with my custom class that I've built here. And so here you can see that I could just define a private level variable and a public property that exposes the value of this variable. And the reason we do this is so that we can actually implement business rules right here within the definition of this property to ensure that the values that we populate our properties with are valid business, make valid business sense. So I'll show you a little bit about what I'm talking about in the next example. But let's go ahead and just create a new custom property. So as we would normally do, we would define the private variable. There are different coding conventions for exactly what kind of syntax you use to name these particular variables. One method that seems popular is just preceding any private module level variables with just an m underscore in the variable name. Therefore, later on when you're reviewing your code, you can instantly know, oh, this is a module level variable. kind of keeping it separate from the public properties that are defined for this particular class. But here I'm just going to say, I'm going to create a private variable custom property as string, and then to expose this property, I would give it a name, public property, custom property as string. And here you can see I can just use the default syntax that was inserted based on this snippet. And so what I've just done is I've just exposed a property for my custom class, a property named custom property, and it actually contains a string value. So as you can see, it's really easy to create a class in Visual Basic .NET Express Edition. You'll use this functionality quite extensively as you begin building .NET applications based on Visual Basic .NET. And so, the editor, it's nice to see the editor features as well. That kind of saves you a little bit of time by going ahead and inserting the appropriate syntax. So now what I've done is I've created this custom property. So clients that use this class can simply use this this custom property name to specify attributes for this particular class. And so now, a couple things about classes. Now what I can do is, now that I've defined all the data and actions that a custom class can take, it makes it very easy to reuse this code across applications. And so any future application that requires me to model an object after a custom class, in this case, I can simply reuse this class across those other applications. And then, as a custom property, as the blueprint gets refined and evolves over time, then I can just come to this one single class to update this particular blueprint update it in one single place so that all future applications that use this custom class are updated automatically as I update this code. So it's great for reusability. It's great for maintainability because I can, update, all applications that use a custom class blueprint. I can update it all in one place. And so it's a great way to organize your code as well as plan for maintainability and reusability of this code across other applications as well. So that's how I'd go about building a custom class within VB.NET. I'll go ahead and we won't need this class for this demonstration. I just wanted to show you how the Visual Basic .NET Express Edition actually makes it very easy to build a class to get started with. So we talked a little bit about properties. This actually defines attributes for our particular class that we are defining, and it utilizes the accessor statements for accessing the values contained within these properties. So the get accessor actually returns a property value. The set accessor actually stores a property value. So let's switch back over to the code sharing demonstration again, and I've built a simple little application here that we're talking about the person object and how you would go about mimicking that object with a class definition. So let's go ahead. I've done that now. I've created a class to represent a real world object, a person, and so here you can see that I've used the class statement to define my person class. So this is a blueprint for how a person can be implemented with software. And so here you can see I've got some constructors. We'll come back to the constructors in a moment. But here I've defined two properties that describe a person. And so therefore I've created a name property, and we also have an age property as well. And so here what I've defined that private variable. The private keyword means that only the code within this particular class can modify the value of this private variable. And so another thing you'll notice too is that I've exposed a name property as, and I've given it a data type as well. And then I use the accessors to retrieve and to update the value of this property. And so here you can see that in order to retrieve the name, I implement the get accessor, and I simply return the value of my local module level variable that actually contains the value. And then, of course, I also implement the set accessor. Notice that the set accessor stubs out a parameter, a value that is being specified. And this value will be used to update the value of my module level variable. So basically what I'm doing is I'm encapsulating the functionality of specifying the property value for this particular class. And what this enables me to do is this enables me to implement business rules as part of enforcing a valid person when it's used by other applications. And so here I'm not actually implementing any business rules. Here you see I'm just implementing the get accessor to return the value of the property, and then the set accessor to specify the value. Now for the age property, I'm actually going to implement a business rule here. And so for the age property, to retrieve the value, I simply implement the get accessor here. And so it just begins with the keyword get, and then the implementation of retrieving that value, and then it's also ended with a end get statement. Likewise for the set statement, that specifies the value. But here I'm going to implement a business rule. So when the value comes in, when it's specified by another application, by a client application that uses this, I'm going to interrogate the value of this property that they're assigning, and I'm going to implement a business rule here, and I'm going to specify, if the value is less than 2, then I'm going to show them a little message that says, you must be at least 2 years old to use this application, and then I'm going to specify that the age is 2. So in other words, I'm implementing a business rule here that specifies that specifies a range, for instance, of what are valid age values for a person class or for a person object. And so therefore, if the value is not specified, or if the value is specified as something that's less than 2, I'm going to implement a business rule and say, no, age has to be at least 2. Now otherwise, I'm just going to go ahead and specify the value of whatever was provided by the application that's using this object. And so here, this is a great way, this is a great example of specifying, why would I want to use a property accessor for assigning values to my attributes for a particular object. And this is a great example of, utilizing the property accessors. I can actually implement business rules that validate the data that's contained for these attributes. So I can enforce that the attributes for this particular object are in fact valid against whatever business rules we need to implement. Now the reason I say this is because I can actually achieve the same functionality by simply specifying this age as a public variable. And then what this does is this would still allow the client applications to update this age property, but there is no validation. It would be completely up to the application that's using my person class. It would be completely up to them whatever they want to specify for age, which could cause some inconsistencies throughout my system, especially if I make assumptions based on what the value of the valid value of age would be for a person object. So even though this statement is similar to the property statement, it's actually completely different in the way in the control that I have from a class level over the value of variables. So just wanted to point out the difference there. A lot of people are confused because a lot of people are confused when they go to implement this, because you can actually achieve the same thing with a public variable, but it does not allow you to enforce any business rules that you may have, so that you can ensure consistency across the values within your classes. So what I've got here is I've got a person object that is defined, and we'll actually walk through this person class in just a moment. But first, let's go back to the slide deck and talk a little bit about objects. So now that we've got a blueprint for how to create a person within our application, now we can actually use an instance of this person to create a unique person object for use within our applications. So, I mean, everything in the universe is an object, so we model real-world objects in software utilizing a blueprint that defines, what this object, that defines attributes such as properties for everything concerning that object, as well as any actions that that object can take. The object is actually an instance of this blueprint. So the class defines the pattern for the object, and then an object is actually an instance of this class. And each one is unique. So that person blueprint is used for creating all person objects. And then as I create instances of this person object, each instance is unique. So while you and I are both people, my age may be different, my height, weight may be different, etc. And so I am a unique instance of a person, and you are a unique instance of a person. We're both based on the same blueprints, but we both define different properties or have different properties associated with us that make us unique. So that's the difference between a class and an object. So creating an object in Visual Basic.net, utilizing a default constructor, we simply declare name, in this case is our variable name, as a new, we use the new keyword to create an instance of our class, and then whatever the name of the class is, open, close paren, and there are no semicolons here. It's a different language. So VisualBasic.net, we don't need those semicolons, so apologize for the typo on the slide deck. We can also define optional constructors as well. So a constructor is a piece of initialization code that is executed when a new instance of your class is created. These constructors go ahead, like I said, this initialization code, so it may define some default values or perform any other initialization that is required in order for our object instance to properly run. So let's go ahead and take a look at using a class as a blueprint to create an instance of that class. So here I've got a simple little application here that just provides for the user interface for creating a person object. And so therefore, if we look at the code here, you can see that upon form load, this is the event handler that fires when this form is loaded, then we're going to create an instance based on our person class. And so here I'm just declaring new person. This is the variable name that's going to contain the instance of our person class. And then I'm going to create it. I'm going to use the new keyword. We use this keyword to create a new instance based on our person class. And then the name of the class itself. So this correlates directly to, within my person class, this correlates directly to the name that we've assigned our class using the class statement. And so there, I'm using a open and closed paren. Now what I'm specifying here is to use the default constructor. And then once I do that, I'm going to call this this little function that's going to add the values of this person's attributes, those properties that we've defined. I'm simply going to add that to the user interface. And if I right-click on this person class and go to definition, it'll take me to the definition of this class. Now, to define a default constructor in Visual Basic for a class that we've defined, we simply declare a public subroutine called new, and with no parameters. This is going to be our default constructor. So anytime someone creates an instance of a person class, this is the constructor that will run when no parameters are defined in that instance creation. So I'm going to assume some default values for some properties that I've defined here. So as a result of creating an instance of a person class, no name is specified, so I'm going to assume that this person's name is anonymous. And then also, since no age is defined, I'm going to assume a default age of 2. Now, I can also define optional constructors as well. These are constructors that are exposed to client applications that that you can specify default behavior or default data for this particular instance. So in my case, I've declared a constructor, again called public sub new. The difference here being that this one accepts a string parameter. And so what I'm specifying here is that if you create an instance of a person class, you may want to assign a default name to use for this class. If that is the case, you pass in a string parameter, and my class blueprint looks at the constructor signatures. In other words, the name of the function as well as the parameters that are provided, and it matches that against a constructor that I've defined for my class. So if I just pass in a single string parameter, it's going to use this constructor, and it's going to take that string parameter you specified and assign that to its internal name property. And then, of course, no age is specified here. So again, I'm going to assume that this person is 2 years old. I've also defined one additional constructor, just so you can play around with this when you download the code later. Just so you can play around with it, I've defined another constructor that accepts a string parameter as well as an age or an integer parameter. So basically, if you create an instance of a person and specify a string as well as an integer, then my class here is going to assign that string parameter as the name property and that integer parameter as the age property. Now, a couple little things to point out here is that notice that I'm actually using the name of the property here, as opposed to, you know, I can do this, right? I could use my private module level variable because it is within scope. It's defined at the class level. So that is certainly valid to use within my constructor. However, if I'm enforcing business rules as part of my property definitions, then I'm actually bypassing any of those business rules here by assigning it directly to the private module level variable. So therefore, it's actually a better practice for assigning my properties containing all of the business logic in that property accessor. And so therefore, anytime I assign these property values within my class, I should use the property accessor, even though it's still internally. So therefore, I know for a fact that I've only got one place to implement any business rules that must be enforced for a name property and any business rules that must be enforced for an age property. And so therefore, by utilizing this default constructor, you pass in a name, you pass in an age. I use the public property accessor, the set accessor, for this name. And so therefore, this is the code that's executed. And likewise, for age, by utilizing the set accessor for age, then it's ensuring that I'm actually going to execute this code block when I assign a value. And as you can see, this is where my business rules are contained for an age property for a person instance. And so by using the set accessor even internally, I can ensure that I can enforce my business rules by placing all the logic for my business rules directly within this set accessor block for my age property. So that's pretty cool. Let's go ahead and let's just walk through an example here. And what we'll do is let's actually go back to our form code, and then we'll set a breakpoint. I'm hitting F9 on my keyboard. F9 places a breakpoint within my code, and basically a breakpoint allows me to step into my lines of code to ensure that that it's operating as intended. So I'm going to hit F5 here, and then we're going to go ahead and run this application. So it actually pauses on my first line of code here, and here you can see that it's come to my instance creation statement. So I'm declaring a new person as a variable. It's called new person, and I'm going to use a default constructor for my person class. And so, I can step through my code by just hitting F8 on my keyboard. I can also do debug and step into. I'm just going to go ahead and hit F8. Notice that it calls the default constructor. And so its default constructor says, okay, I guess you're anonymous, so I'm going to assign the name property anonymous, and then I'm going to assign an age property of 2. And then I'm going to add this person to the list box. Notice that when I add this person to the list box, it jumps into the get accessor for the name property defined for my person class. And so it's going to do it once again. I'm actually utilizing the age property within this list box statement as well. So it's going to jump to the get accessor for the age property, and then it'll actually update the user interface. And then so if I just hit F here, what I'm doing is I'm actually creating an instance based on the person class, but I'm going to use that default, I'm going to use the constructor that matches passing in a string. And so the compiler will match this up, and it's utilizing the constructor that I defined that accepts a single string parameter. And so it says, oh, okay, so as part of creating this person, you're going to go ahead and assign a name to it. And notice how it jumps to the set accessor for the name property, and then no age was specified, so it's going to assign a default value for age, in this case being 2. And then once again, I'm going to add this to the user interface. And then finally, I'm going to create another instance of a person, and this time I'm going to pass in a string and an integer value. And so then it's going to match up the constructor that accepts a string and an integer value, and it's going to specify the name and age property based on these values. So these are different ways that I can create an instance of a person class. So if I just go ahead and execute, notice that my user interface was defined, my user interface was updated, and I've now got 3 people that I've added to my list box that were created. 3 different ways of creating an instance of a person class. It looks like I got a couple questions here. Let me go ahead and switch back to the slide deck for a second, and let's see what kind of questions we have in the queue. So in a couple of questions that I have in the queue, let's go ahead and talk about right now. What would be an appropriate method to validate the value passed to a set accessor? Should there be a try inside the set? So that's a great question. So the question is, how exactly should I validate the value here? Let's go ahead and switch back to my code sharing demonstration for a second, and switch over to my person class. And so here you can see within my set accessor, I'm actually validating this value here. So I'm specifying, hey, if the value is less than 2, then I need to take an appropriate action. In this case, I'm displaying a message box, which typically isn't a great idea to display any user interface elements from within your class functionality, simply because you're limiting that class to only handling user interfaces that are specific for this particular application. So in this case, my person class, I'm limiting my person class to only be used in Windows applications because I'm utilizing this message box function. It's just an easy way for me as demonstration purpose to show the validation. In most cases, what you do here is you could raise an error from within this code block here. Instead of showing a message box, a better practice would be to raise an error here. And then what you would actually do is you would actually put the try block in the client application when you try to assign a value. So in this case, I would put a try block. I'd put my values to specify for these properties within a try block within my client application, and then it would trap for invalid range for age property or something like that. And then within my class, if this business rule were violated, this age verification rule here, then I would actually raise the error back to the client application and say, age valued not in proper range, valid ranges are at least 2 years old, or something of that nature. The client application would trap for that error, and then the client application would actually display that error message to the user. And so therefore, that's typically what you would do in order to validate business rules within your set accessors on your properties, is you would in fact raise an error back to the calling application. So that was a great question, and hopefully I answered that one pretty good. Here's another great question. Is a default constructor required? No. A default constructor is not necessarily required. Notice when I just created a class and called it a custom class, it didn't actually create a default constructor for me. However, it's doing that behind the scenes, though, really and truly. So if you don't define a default constructor, it's just going to use a very generic default constructor for you. It's going to actually, the compiler will actually insert a default constructor for you if you don't specify a default constructor. So you don't have to specify that, but it does give you an option for specifying a default constructor. And then, can an optional constructor be defined without having a default constructor defined? And the answer is yes, you can. And then, how do you raise different kinds of errors from the class within a single property? And then within Visual Basic.net, you would actually use the error object to actually raise an error to the application, and then the calling application would catch that exception. In its exception handling code. So you would actually do that from within the set accessor within your particular class. All right. So think of. Let me just check the other questions here. And then here's another great question. In Visual Basic.net 2003, I could get away without using properties. Is that not true in 2005? What am I missing by not using properties? I just scoped the variables as friend. And so what you're actually losing, that's kind of what I explained earlier, how you can define a public variable, and to a calling application, it's going to look just like you defined a public property. What you're missing by not using properties, though, is you're actually missing the ability to validate any data that's passed in, or that is specified for that property. So you have no control within your class. If you just expose a variable as public, then you have no control over any data that is specified for that property. Whereas if you use properties, you can implement business rules that will validate that data and ensure that it's valid data before you assign it to a property value. So hopefully I explained that one pretty clearly. And then, what's the syntax for utilizing objects? We already kind of took a look at this. I kind of skipped ahead, I guess. But basically for properties, it's just object.property equals value. And then to get the property's value, it would just be variable equals object.property. Now, we also can define methods as well. And these define actions that the object can take. And so when we specify an action, these are defined as methods or functions. Methods are invoked that don't contain any return values. Functions are defined for code that returns a value. And so just looking at some of the code that we specified for utilizing these properties and then methods, I've also defined on my person class, I've also defined a method as well, a public method, say hello. This is an action. It does not contain any return values, so therefore it's defined as sub. And then here you can see that this is just code that's going to execute when I call say hello on this person class. So if I go back to my code, and basically I've created an interface that allows you to create a person, specifying the name, specifying an age, and then allowing you to also invoke that hello, that say hello method once the person is created as well. And so if we double click this button, you can see that I'm going to create a new instance of a person class. I'm going to assign properties of this instance. So specifying the name is simply this variable name. This is my instance name here. And then dot name. Now Visual Basic.net will give me IntelliSense as well. So when I do this, say dot, it'll give me the class's interface. The interface is just a term used to describe how we use this object. And so here you can see that it's got two properties defined, age and name. Notice as I hover over it in my list box, the editor also gives me, as a tooltip, gives me the entire definition of this property. And then it's also got one method defined, say hello. And so here you can see the icons are slightly different as well to denote whether these are properties or methods. And so now we just do new person dot, and then of course we could specify one of these properties. Here I'm specifying name, new person dot name equals, and then whatever I want to assign to it. Here I'm going to read the text property of the name text box that I've defined in my user interface. So whatever text you type in that first text box is what I'm going to assign to the name property for this person instance. And then also I'm going to specify, if you type in something for age, then I'm going to convert that to an integer and specify that as the value to use for the age property. If you don't type anything in, then I am not going to specify an age property, and so therefore my class is going to implement the way to specify a default value for age. Once again, I'm encapsulating all that code within my class. And then here I'm simply going to add this new person to the user interface. And then finally, I'm going to check to see if that Say Hello checkbox is checked. If the Say Hello checkbox is checked, then I'm also going to call the Say Hello method on my instance of this person class. And then I'll just kind of clear out the user interface after I've created this person. So if I execute this, if I hit F5, I've still got that breakpoint in there, so I'll hit F5 again. And then so if I specify Ron, don't specify an age, create, you can see it just adds me to the list box. Remember, my default constructor actually assigns an age value of 2 if you don't specify one. And then, let's see, another Jane Doe here, age 21. And then here I'm going to say, I want to say hello. I want to call the Say Hello method on this new person object. Click Create. And here, this is the implementation of that Say Hello method, hello from Jane Doe, and I'm 21. And notice it added it to the list box as well. And so that's how we define a class, define properties and methods for a class, and then from a client application, this is how we create an instance of a class known as an object, and then utilize that object to represent a unique instance of this class. So today was an overview of classes and objects in VisualBasic.net. So we defined exactly what a class is and what it's used for, and then we also defined exactly what an object is and how we can create and use those objects within our applications. So now this is part 6 of a 22-part webcast series. Next week we're going to be talking about operator basics in VisualBasic.net. So I hope you'll join me for that. And once again, I'll be posting this sample code to my blog shortly after the conclusion of this webcast. You can review that at blogs.msdn.com/Ron_Cundiff. So what I'm going to do now is I've got a couple questions in the queue. I'm going to go ahead and start answering questions and turn it back over to Craig.
All right, fantastic, Ron. Great presentation. Would like to share some additional resources with our MSDN crowd here. We will get to our question and answer session in just a moment, but once again, feel free to go ahead and ask away. Go down to the bottom of your screen, type your question in next to the Ask button, and then simply click that Ask button. As I mentioned earlier, you can view a replay of today's live event or register for some upcoming webcasts by going to www.microsoft.com/webcast. The streaming media replay and downloadable WMV file will be available within 24 hours. I'm going to be providing a survey for today's event in just a moment. And if you could, please take a few minutes to complete today's survey. The feedback and comments that you provide just allow us to create some better webcasts for you, so your feedback is greatly appreciated. If you've got an idea for a webcast or you'd like to see some specific content developed, you can go ahead and point your web browser where I just pointed that arrow on your screen, and we at the webcast team will do all that we can to bring you a webcast of that content. Now, by attending this webcast, which you all have obviously done, and submitting the evaluation, which again we will get into here in just seconds, you will be entered to win a 30 gigabyte Zoom digital media player. So just by taking a few moments of your time, have an opportunity to win some pretty cool hardware. So without further ado, here is that survey. If you could, just go ahead and follow the links that are provided in your interface right now and complete today's webcast evaluation. Again, your comments are quite valuable to us. At this time, I will go ahead and throw the floor back to Ron so he can answer some of the questions that have come in.
Oh, sorry, I was busy typing away. So there are a couple of different questions here. How do you create a custom attribute for a class? Are you just talking about the? I'm not exactly sure what you mean by that. You just mean, for instance, custom property? I'm not exactly sure what that question's for. And then that's just a follow-up from another question. There's one other question about raising different kinds of errors within our property. Tell you what, I'm going to find you. I'm going to find you an article that'll show you exactly how to do that, and I'll put them on my blog right after the webcast, so you can get real-world examples on it. I mean, you basically use the error object in VB, but I'll put a link to the article on my blog. And that's all I got for right now, Craig.
All right, well, fantastic. Well, we will remain online for the next several minutes. Once again, feel free to go ahead and submit your questions. We will answer them via the question and answer text window. With that, I would like to extend a special thank you to Ron for his presentation today. I also want to thank everyone for attending today's webcast. Ladies and gentlemen, that is going to conclude our MSDN program. Thank you again for joining us, and we look forward to seeing you again soon. You may now disconnect from the audio portion of this conference.